Welcome students. Hope you all are keeping good and safe at home. In the previous class, we have studied about the basic concept of functions. Okay, I hope that concept is clear to you, which you have already studied in 11th class. Today, we are going to see what are the different types of functions. Okay, in the previous class 11th, you have studied types of functions, but that is according to the graph. ठीक है ना. अब यहाँ पे जो है हम पढ़ेंगे टाइप्स ऑफ फंक्शन एज पर द मैपिंग्स. ठीक है, मैपिंग्स के इसमें कितने टाइप्स ऑफ फंक्शंस है और वो कैसे काम करते हैं, कैसे आप उसको क्वेश्चंस में अप्लाई करोगे. करेक्ट. नाउ यू कैन सी इन माय स्लाइड द टाइप्स ऑफ फंक्शन. That is, the first is your one-to-one function, which is also named as injective functions. Okay. The second is your on-to function, which is also known as surjective, and the third is one-one and on-to, which is also known as bijective functions. Okay. Now let's see the first one, that is one-to-one function. You can see in my slide that a function f mapping from x to y is defined to be one-to-one or injective if the images of distinct elements of x under f are distinct. That is, for every x1, x2 belongs to x, fx1 is equal to fx2 implies x1 is equal to x2. Otherwise, f is called many one. Here you can see a diagram also in which I have taken two sets x and y. In x you can see there are numbers 1, 2, 3, 4 and in y a, b, c, d, e, f. See, if you observe this, you can see here every element of x has got a distinct image. 1 has got image a, 2 has got b, 3c and 3d and 4c. Okay, that means each and every element of x has got distinct image. So when you are getting a condition like this in which the first set has got images distinct, that means all the elements of the first set will be having a distinct images in the second set, then you can say that function is one-to-one. Now let's see one more example in the board. Now I am taking one example here. F is a mapping from R to R. Okay, I am taking a function from R to R. What is R? R means set of real numbers. Okay, defined by fx is equal to 2x. Okay, I am taking a function fx is equal to 2x. Now let's see whether this function is one-to-one or not. Okay, now fx is equal to x. The set is R to R. That means this is the set of real numbers. This is also a set of real numbers, R to R. Now here I am taking numbers like 1, 2, 3, 4, 5 and 6. I have taken these numbers, okay, in the first set. Now let's see, when you put, this is called the domain. You all know the first set is called the domain and the second is called the codomain. Now when you put these values into this, what you are getting, let's see. Now when you put 1, 2 into 1, you are getting here 2. आप यहाँ पे भी लिख सकते हैं 1, 2, 3, 4, 5, 6, 7, 8. ठीक है, ये भी रियल नंबर्स मैंने लिख दिया यहाँ पे. अभी जब आप x की जगह पे 1 लगाएंगे तो आप देखिए आपको क्या मिलेगा वैल्यू 2. That means the image of 1 is 2. When you put the value of x as 1, you'll see that the image is 2. When you put 2 here, the image is 4, and when you put 3, the image is 6, and when you put 4, the image is 8. Like that, आप देखेंगे every element of this set will be having a distinct image in set Y. ठीक है, मतलब इसके जितने भी एलिमेंट्स होंगे ना, उसका जो इमेज यहाँ पे बनेगा वो सारे अलग अलग होंगे. ठीक है, हर कोई एलिमेंट, अगर आप -1 लोगे तो -2, क्योंकि ये रियल नंबर है, यहाँ पे -2 होगा, हाफ होगा, फ्रैक्शंस होंगे, सारे टाइप के नंबर्स होंगे रियल नंबर में. तो आप देखोगे आप यहाँ पे जो भी एलिमेंट, जो भी नंबर आप x की जगह पे डालोगे उसका एक ही इमेज होगा जो कि आपका कोडोमेन में होगा. ठीक है, तो what is the meaning of one-to-one? That means each and every element of the first set will be having a distinct image in set y. ओके, सेकेंड सेट में उसकी जो इमेजेस होंगी वो सारे अलग अलग होंगे, तब हम उस तरह के फंक्शन को बोलते हैं one-to-one. Clear children? Now we'll go for the second one, that is on-to function. Now before explaining on-to function, I'll tell you one more thing. यहाँ मैं एक और चीज़ मैं बताना चाहती हूँ, एडअप करूँगी यहाँ पे। अभी यहाँ पे आप देखिए, आप ले रहे हो यहाँ पे x1 और x2. I have taken 2 more numbers here, x1 and x2, and the images are here fx1 and fx2. Okay, now you see here, ये तो था कि मैंने एग्जाम्पल आपको बता दिया, but mathematically how you are going to prove that function is 1 to 1, that you should know it. यहाँ पे देखिए, mathematically what we are telling, if fx1 is equal to fx2, अगर ये दोनों इमेज सेम हो जाते हैं, ठीक है, अगर ये दोनों इमेज सेम हो जाते हैं तो x1 is equal to x2 आना चाहिए. That means suppose we are taking two elements x1 comma x2 taken from the domain R, okay, and we are getting fx1 is equal to fx2, implies that x1 is equal to x2. अगर ऐसा हमें मिल रहा है, so we can say that the function, this function is what? 1 to 1 function. So this is the way of mathematically आपको प्रूव करना है. अगर ये दोनों इक्वल हुए, इमेजेस इक्वल है, तो डेफिनेटली जो नंबर्स होंगे, जो डोमेन के जो एलिमेंट्स होंगे वो भी इक्वल होने चाहिए, तभी आप बता सकते हो कि डिस्टिंक्ट इमेज उसका आया हुआ है. ठीक है, अब इस क्वेश्चन में हम इसको कैसे प्रूव करेंगे? See here, fx1 is equal to fx2. The value of fx is 2x, that means it is 2x1 is equal to 2x2. Now that implies 2 gets cancels out, the value is x1 is equal to x2. So finally you got it, fx1 is equal to fx2 implies that x1 is equal to x2. Hence you can say that the function is a 1 to 1 function. Now suppose it is not 1 to 1, that means it will be what? f is many one. ये एक और टाइप है many one function. कब हम बोलते हैं many one? When you will say that the function is many one. आप यहाँ ध्यान से देखिए, सपोज अगेन आई एम टेकिंग अ फंक्शन r to r defined by fx is equal to x square. Okay, I have taken a function fx is equal to x square. Now r to r, this is our set of real numbers, this is also set of real numbers. I am taking the value here -1, 1, 2, -2, like that numbers. और यहाँ पे मैं numbers ले रही हूँ 1, 2 ले लिया मैंने, 3 ले लिया and 4. Okay, I have taken the numbers. Okay, आप माइनस भी यहाँ पे ले सकते हो because we are talking about set of real numbers. Now fx is equal to x square. That means when you put the value of x as -1, तो उसका इमेज क्या होगा? 1 होगा, है ना? When you put the value of x as -1 the whole square is 1. So you got the image of -1 is 1. Clear? Now here see, when you put the value of x as 1 square, again the image is 1. That means the image of -1 and 1 is 1. दो एलिमेंट का एक इमेज आपको मिला यहाँ पे. ठीक है, सेम वे 2, the image of 2, when you put 2 here, 2 square means 4. When you put -2, again 4. So you observe that here 2 elements, that is why the name is many one. Many का एक इमेज, उसका जो मतलब होता है वही है. देखिए many का एक इमेज, देखिए तो यहाँ पे देखिए ये दोनों एलिमेंट्स के एक इमेज है, यहाँ पे भी दोनों एलिमेंट्स के एक इमेज है. सो यू कैन से दैट द फंक्शन इज नॉट 1 to 1, इट इज व्हाट? इट इज many one. बहुत सारे एलिमेंट का एक इमेज होना. समझ में आ रहा है आपको? सो दिस इज अ वेरी गुड एग्जाम्पल इन विच यू कैन से दैट इट इज नॉट 1 to 1, it is many one. I hope the concept of 1 to 1 and many one is clear to you. Okay. Now one more thing I want to tell you. आपको पता होगा ये डोमेन है. जो पहले जो सेट के जो एलिमेंट्स होते हैं that is known as domain, and the second set is called the codomain. Now what is range? This you have already studied in 11th class. Range किसको बोलते हैं हम? देखिए अगर आप यहाँ में बात करें, जब आप इसका जब आप पेयरिंग करते हैं तो आप कैसे लिखोगे? 1, 2, ठीक है, यहाँ पे लिखोगे 2, 4 and then you will write down 3, 6 and then 4, 8. You're not, see you're writing only those numbers which are mapped. जिसकी images है वही लिख रहे हैं आप, है ना? आप सारे numbers नहीं लिख रहे हैं पेयर में. ओके, सो जो numbers आप लिख रहे हैं ना ऐसे ordered पेयर में, that numbers are called range. Okay, that means how you're getting range? When you put the value of x, when you put the value of x what is the answer you are getting, the value of y you will be getting, and that is known as range. जब आप x के वैल्यू को डालते हैं, जो वैल्यू आपको मिलता है वो क्या कहलाता है, range. Okay, so here the range is 2, 4, 6, 8 like that it goes. ठीक है, सारे आपको यहाँ पे इवन नंबर्स मिलते जाएंगे, बाकी जो ऑड नंबर्स है वो इसके रेंज में नहीं आएंगे. बट व्हेन यू टॉक अबाउट कोडोमेन, कोडोमेन मींस द कंप्लीट सेकंड सेट. सो द कॉन्सेप्ट ऑफ डोमेन, रेंज एंड कोडोमेन हैज टू बी क्लियर, क्योंकि आप जब आगे क्वेश्चंस करोगे ये सारी चीज आपको पता होनी चाहिए. ठीक है, नाउ लेट्स सी ऑन टू फंक्शन. व्हाट इज ऑन टू फंक्शन? यू कैन सी इन माय स्लाइड. अ फंक्शन f mapping from x to y is said to be onto, or the name is surjective also, if every element of y is the image of some element of x under f. That is, for every y belongs to capital Y, there exists an element x in x such that fx is equal to y. You can see diagrammatically also, I have taken two non-empty set x and y. In x you see the numbers are 1, 2, 3, 4. In the second set you have a, b, c. You can see here the image of 1 is a, the image of 2 is a, 3 b and 4 c. All the elements of y, okay, all the elements of y is the image of some or other element of the x. First set, okay, मतलब कोई भी एलिमेंट यहाँ में लेफ्ट आउट नहीं हुआ है. आप देखिए सेकेंड सेट में ऑल द एलिमेंट आर द इमेजेस ऑफ सम और अदर एलिमेंट ऑफ द x. ओके, तो आप यहाँ पे ये बता सकते हैं कि जब कोई भी एलिमेंट छूटता नहीं है, एवरी एलिमेंट, हर एक एलिमेंट y में जो होना चाहिए उसका प्री इमेज होना चाहिए. एक और चीज बताऊंगी यहाँ पे, ये जो होता है इमेज, दिस इज कॉल्ड इमेज. व्हाट अबाउट दिस वन? दिस इज कॉल्ड प्री इमेज. क्या बोलते हैं हम लोग? प्री इमेज. ओके, प्री इमेज एंड दिस इज योर इमेज. So that means a function is said to be onto when what you can say, every element of y is the image of some element of x under f. Okay, and mathematically if you see, the second definition says that is, for every y belongs to capital Y, there exists an element x. That means for every y there should be one x, okay, such that fx is equal to y, such that fx is equal to y. Okay, now let's see one more example. See, I am taking the same example. F is a mapping from R to R defined by fx is equal to 2x. Okay, now let's see this function is onto or not. Now the concept of onto is that no element should be left out in the codomain. Okay, now let's see, suppose this is a set R, this is another set again R, set of real numbers. I am taking elements 1, 2, 3, 4, 5, 6. I can take half also, और भी कई नंबर माइनस में भी आप ले सकते हैं. यहाँ पे भी 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now when you put the value of x, that means 1 when you put, you are getting the answer to be 2. When you put 2, यहाँ पे 2 डालेंगे तो क्या मिलेगा? 4. जब आप 3 डालोगे तो आपको क्या मिलेगा? 6. ठीक है, 4 डालेंगे तो 8 मिलेगा, है 5 डालेंगे तो यहाँ पे 10 आएगा, 6, हर एक नंबर. अभी आप हाफ डालेंगे, सपोज व्हेन यू पुट हाफ, आपको क्या मिलेगा? 2 गैस कैंसल्स आउट, द इमेज इज 1. सो यू विल सी, अभी आप x की जगह में कुछ और एलिमेंट डालें तो वो 5 भी मिलेगा. ठीक है, तो आप यहाँ पे क्या देखेंगे कि आपको कोई भी एलिमेंट जो है ना इस कोडोमेन में नहीं छूटेगा. हर एक एलिमेंट जो है किसी ना किसी एलिमेंट का इमेज होगा. ईच एंड एवरी एलिमेंट of the set B will be the image of some element of x. Okay, that means we can say that this function is onto function. Clear children? So that is very very important. आपको ये चीज याद रखना है कि no element should be left out in the second set. That means in the codomain. If you are telling like that, if you are getting an answer like that, you can say that the function is a onto function. Now जब कोई भी element इसमें नहीं छूटा होगा, that means you can say that the codomain is equal to range. That means if the codomain and range are same, range is what? Range मतलब जो आपके मैपिंग में आ रहा है. और यदि कोई भी एलिमेंट, every element is mapped, that means every element is the image of some or other element, that means what? The codomain and range both are same, and when these two are same means the function is a onto function. Clear? The other is, for every y belongs to y, there exists an element x in capital X such that fx इज इक्वल टू वाई, ये आपको मैथमेटिकली आपको इसको प्रूव करना है, ठीक है, लेकिन कॉन्सेप्ट जो मैंने अभी बताया वही है. नाउ लेट्स सी another last one, that is one to one and on to function. It is very simple. We have already learned one to one, already know what is on to function. That means a function f mapping from x to y is said to be one to one and on to if f is both 1 1 and on to. That means a function should be both 1 1 as well as on to. No element should be left out in the set B, and each and every element of the domain should be having a distinct images. If this condition is there, you can say that the function is one to one and on to function, or you can name it to be bijective function. Diagrammatically also you can see two sets I have taken, non-empty set x and y, 1 2 3 4. See, each and every element has got distinct images and no element is left out in set y also. So you can say this function is both 1 1 and on to, hence it is a 1 1 and on to function, or you can say it's a bijective function. Okay, now let's see the exercise problem, exercise 1.2. Look at the first question. Show that the function f mapping from r star to r star defined by fx is equal to 1 by x is 1 1 and on to, where r star is the set of all non-zero real numbers. Okay, the second part is the result true if the domain r star is replaced by n with codomain being same as r star. Now see here, the question is f is a mapping from r star to r star. So what is r star here? R star is the set of all non-zero real numbers. Set of all non-zero real number means what? R star is nothing but r minus 0. You have all the real numbers except 0. The meaning of r star, what in this question is given to you as, it is the set of all non-zero real number, means it is real number minus 0, except 0 all the real numbers you have to take. Okay, now the question is you have to show that defined by fx is equal to 1 by x is 1 to 1 and on to. Now we will first see 1 to 1 function, which is also named as injective. Okay, we will see whether this function, since it is a show that function, that means we have to show that the function is 1 to 1. Okay, I told you 1 to 1 कैसे prove करते हैं. We have to take let x1 x2 is taken from r star. From the domain we have taken two elements x1 and x2. Okay, we will see fx1 is equal to fx2 implies x1 is equal to x2. हमें मिल रहा है कि नहीं ये हम देखेंगे यहाँ पे. fx1 is equal to fx2 means what? What is fx1 here? 1 by x1. What is fx2? 1 by x2. That means x1 is equal to x2. You got it? So what you have proved here, fx1 is equal to fx2 implies that x1 is equal to x2. Hence what can you say? You can say that f is 1 1. Clear? So here we have proved that the function is 1 1. Okay, so this is the way you have to proceed when you do a question. Okay, now the second is you have to prove onto function. Let's see how to prove onto function. Onto function, onto means यहाँ पे surjective. Okay, surjective. Now onto means I told you that for every element, for every y in the codomain there should be x in capital X such that in the domain such that fx will be is equal to y. So let's see how to prove this question. Now fx is equal to 1 by x. ठीक है, fx is equal to 1 by x. That means y is equal to 1 by x. Okay, that means that implies that x will be is equal to 1 by y. ठीक है, यहाँ आप ध्यान से देखिए, यहाँ पे देखिए ये onto function भी है. क्यों है? क्योंकि आप कोई भी एलिमेंट, इट इज अ फंक्शन इज अ मैपिंग फ्रॉम r star to r star. Any element if you take it in the codomain, it will be definitely the image of, it will be definitely the image of some element of x. कोई भी एलिमेंट आप ले लीजिए. ठीक है, तो आप यहाँ पे कैसे बता सकते हो मैथमेटिकली? आप कैसे बताओगे? fx 1 by x है, that means y is equal to 1 by x. That implies that y is equal to 1 by x, and that implies that x is equal to 1 by y. That means you can write down that for every y belongs to, you are taking for every y belongs to the codomain, हर एक एलिमेंट जो कोडोमेन का होगा, for every y belongs to R star, there exists x is equal to 1 by y. आपको क्या मिला, एक x मिलेगा जो 1 by y होगा, and it will be present in this thing R star, that is nothing but domain. Okay, ये कोडोमेन की बात कर रही हूँ, and this I am talking about the domain. For every y belongs to R star, there exists x is equal to 1 by y which belongs to R star, that is domain, such that हमें क्या प्रूफ करना है, fx is equal to y आना चाहिए. When you put the value of x as 1 by y, you should get fx is equal to y. Let's see, f of x का जगह पे क्या लिखेंगे हम, 1 by y लिख देते हैं, that equals to 1 by x. So 1 by x की जगह पे 1 by y, ये क्या हो गया y और ये क्या हो गया fx. That means you finally got it, fx is equal to y. This is the way you have to proceed. ये चीज़ आपने ऑलरेडी आपने सीखा होगा. रेंज हम कैसे निकालते थे 11th क्लास में, हम x को y के टर्म्स में लिखते थे, याद है आपको, फिर उसको सब्स्टिट्यूट करके हम वैल्यू निकालते थे. Now in this question one more part is there. Is the result is true if the domain R star is replaced by n with codomain being same as R star? That means if you replace the domain by n, this will be remain as it is, but if you replace the domain by n, then this result will be same. That means you can prove whether it is a 1-1 or onto function. Let's see, if we replace, okay, if we replace the function by n, okay, that means the domain is n here and codomain will be R star only. What they are telling, if you replace the domain by n defined by the same function, whether the function is 1-1 or onto. Now let's see 1-1 or not. See, 1-1 means fully depends on the domain. Okay, this is your R star and this is your n. When you take 1, 2, 3, 4, 5, 1-to-1 function means each and every element of the domain will be having a distinct image. If this condition is there means you can say the function is 1-to-1. So here you see each and every element will be having, जब आप इसको वैल्यू को यहाँ पे पुट अप करोगे ना, आपको सारे एलिमेंट्स जो है आपको उसके इमेजेस अलग अलग मिलेंगे. तो ये 1-to-1 तो है ही, ऐसा ही मैं बता सकती हूँ, क्योंकि हमें सिर्फ डोमेन देखना है. नेचुरल नंबर जितने भी होंगे वो तो इसके इमेज रियल नंबर्स में तो होंगे ही होंगे. सो डेफिनेटली यहाँ के जो नंबर्स होंगे इसके सारे इमेजेस यहाँ होंगे और वो सारे अलग अलग होंगे. सो वी कैन से दैट व्हेन यू रिप्लेस द डोमेन बाय n, it will be again the result will be same, the function is 1-to-1. Now let's see whether it is onto or not. ठीक है, तो यहाँ पे आपको वर्ड्स में लिखना है कि if we replace, you have to write down here, if we replace, okay, replace the domain by n, then the function will be 1-to-1, but not onto. I'll tell you why it is not onto. Whenever we talk about onto is fully depends on the codomain, because what is the definition? Each and every element of y will be the image of some or other element of the x, that means domain. Okay, so यहाँ पे आप देखो, यहाँ पे जैसे कि आप यहाँ पे देखिए, ये तो नेचुरल नंबर है और ये आपका रियल नंबर है जो बड़ा है. यहाँ पे -1 होगा, 2 होगा, -3 होगा, यहाँ पे नेचुरल 1, 2, 3, 4, ठीक है, यहाँ पे 4 हो गया, 5, -6. See, this is all positive number. If you put here any positive number, whether you are getting the image negative, ऐसे पॉसिबिलिटी है, आप कोई भी पॉजिटिव नंबर डालेंगे तो उसका इमेज नेगेटिव आएगा? नो, दैट मीन्स हियर द नेगेटिव वैल्यूज विल बी लेफ्ट आउट. नेगेटिव वैल्यूज हो गए, फ्रैक्शंस हो गए, बहुत सारे एलिमेंट्स होंगे वो लेफ्ट आउट होंगे जिसका कोई भी इमेज डोमेन में नहीं होगा. तो आप क्या बोल सकते हो, ये फंक्शन इज नॉट ऑन टू. एंड हाउ यू आर गोइंग टू गिव द रीजन? द रीजन इज यू हैव टू गिव will be 1-1 but not onto, as if you take -3 belongs to the codomain, as for -3 belongs to R star, we will not be getting any x. X means what? X is equal to क्या आ जाएगा यहाँ पे? x इज इक्वल टू, अगर ये -3 होगा वी विल नॉट बी गेटिंग x इज इक्वल टू -1/3. ओके, बिलोंग्स टू R star, that is domain. Is that clear? If we replace the domain by n, then the function will be 1 1. Okay, but not onto, as -3 belongs to R star, when we take, we will not be getting any x is equal to -1/3 in the which belongs to R star. Domain में हमें इसका कोई image नहीं मिलेगा. So we can say that a function is not onto. I think it's clear. Okay. Belongs to n, which is nothing but the domain. Clear, children? So this part is very important. If you replace the domain by the natural number, that is n, then the function will be 1 to 1. But not onto, as -3 belongs to, or if you take a negative number in the codomain, you will be not getting any pre-image in the domain. X is equal to -1/3, you will not be getting here, and will not be getting any x is equal to -1/3, which belongs to capital N. Okay, that is the domain. So this is the first question. I hope this question is clear to you. In exercise 1.2, first question we have already explained you. Second question you can see, check the injectivity and surjectivity of the following functions. See the first three questions, the functions are same for all the first three questions. Fx is equal to x square. The only difference is the domain and the codomain is different. In the first question, the domain is natural number and the codomain is also natural number. In the second question, you can see set of integers, codomain is also integers. In the third set, it is real numbers. Okay. So in all the three cases, we have to check whether the function is 1 to 1 and onto. Okay. Now, first question, see here, f is a mapping from n to n given by fx is equal to x square. So we will first check whether it is 1 to 1 or not. Now natural number to natural number, आप यहाँ पे देखिए मैंने दो नॉन एम्प्टी सेट लिखा है, नेचुरल नंबर. जब आप देखेंगे नेचुरल नंबर दोनों ही हैं और फंक्शन आपका क्या है, x स्क्वायर है. दैट मीन्स इफ यू टेक एनी नंबर, आप 1 ले लो, 2 ले लो, 3 ले लो, कोई भी नंबर आप लेंगे उसका मैपिंग आपको कहाँ पे मिलेगा, इन द सेकेंड सेट. दैट मीन्स द डोमेन, द मोस्ट इंपॉर्टेंट पार्ट इन द 1 to 1 is each and every element of the domain, that means of the first set should be having distinct images in the second set, and we will show it by mathematically. हम इसको show करेंगे. Let x1 x2 belongs to n. fx1 is equal to fx2 implies that what is the value of fx1? x1 square. So it is x1 square is equal to x2 square. Now you will take x2 square to this side, you are getting the expression as x1 square minus x2 square is equal to 0. Here we will not going to take x1 is equal to minus x2. Why? Because we are talking about natural number, only positive numbers. Okay. So we will take only x1 minus x2 is equal to 0, and that implies x1 is equal to x2. Now when fx1 is equal to fx2 implies x1 is equal to x2. What does this mean? This means that f is 1 to 1 function. Now we will check whether it is onto function or not. Onto का क्या मतलब होता है? Each and every element of the codomain, codomain के जितने भी elements होंगे, it should be having pre-image in the domain. Okay. So इसके हर एक element के pre-image होने चाहिए domain में. अब यहाँ पे आप देखिए, it is not onto because there are many numbers which have no pre-image in its domain. What are the numbers? The function is fx is equal to x square. Okay. What about 2? In this natural number, you will be having 2 also. Whether 2 is a square number? No. So 2 will be left out. 2 will not be having a pre-image in the domain. So 2 will be left out. 3 does not have any pre-image in x because the function is fx is equal to x square. ठीक है. तो मतलब आपको 3 स्क्वायर नंबर नहीं है तो 3 किसी भी एलिमेंट का इमेज नहीं होगा. वैसे ही 5 है, वैसे ही 7 है. So you will be getting many numbers which does not have a pre-image in the domain. So you can say that it is not onto. That is the same thing I have written here. It is not onto because there are many numbers which have no pre-image in its domain. बहुत सारे elements हैं जिसके pre-image जो है domain में नहीं है, तो हम बोल सकते हैं ये function onto नहीं है. तो ये function 1 1 है but it is not onto. Okay. Now come to the second question. The second question, the function is same, fx is equal to x square. The only difference is f is a mapping from z to z. That means set of integers to integers. So I have taken one example here. Set of integers means I have taken -1, 1, -2, 2. Here also I have taken the same number. The function is fx is equal to x square. When you take x is equal to -1, what will be the image? 1. Because -1 the whole square is what? 1. तो -1 का image आपको क्या मिलेगा? 1 मिलेगा. If you take 1, then also you will be getting 1. That means 2 elements is having single image. Okay. And here also -2 the image is 4 and 2 also 4. यहाँ पे भी 2, ये जो है this is an example of many one function. I have already explained you this function. Okay. So यहाँ पे this function is not 1 to 1. Why? How you are going to write down the reason? You have taken 2 elements, -1 and 1 belongs to z. -1, 1 I have taken from the domain. F of -1 is equal to f of 1. When you put -1, you are getting f of -1 is 1. When you are putting x is equal to 1, again f of 1 is 1. So the images are same, but the elements are not same. That means you are getting fx1 is equal to fx2, but x1 is not equal to x2. You can add up here. आप यहाँ पे before this, okay, you can add here fx1 is equal to fx2, but x1 is not equal to x2. Therefore, f is not 1, 1. Clear, children? Now, whether onto, there are many such elements in the codomain which have no pre-image in its domain. It is not onto. So, आप यहाँ पे क्या लिखेंगे पहले? It is, you have to write down. ठीक है? यहाँ पे आप पहले लिखेंगे it is not onto as there are many elements. It is not onto as there are many elements which in the codomain which have no pre-image in its domain. आप यहाँ पे देखिए, ठीक है, जब हम इंटीजर्स की बात करते हैं और इमेज की बात करते हैं, स्क्वायर है ना, तो यहाँ पे रेंज कैसे होगा? रेंज आपको क्या क्या मिलेंगे? सारे पॉजिटिव नंबर्स ही मिलेंगे. यू विल नॉट बी गेटिंग एनी नेगेटिव नंबर्स. ओके, दैट मीन्स द नेगेटिव नंबर्स इन द कोडोमेन विल नॉट बी हैविंग एनी प्री इमेज इन द डोमेन. जो नेगेटिव नंबर सारे छूट जाएंगे, वो किसी के भी इमेज नहीं होंगे. क्यों नहीं होंगे? क्योंकि ये स्क्वायर है. अगर आप नेगेटिव नंबर जब डालोगे तो पॉजिटिव बन जाएगा वो, है ना. दैट मीन्स द नेगेटिव नंबर्स इन द कोडोमेन विल नॉट बी हैविंग एनी प्री इमेज इन द डोमेन. दैट इज व्हाट वी आर गेटिंग. It is not onto as there are many such elements in the domain, codomain, which have no pre-image in its domain. Hence, the function is not onto. इसको आप पहले भी लिख सकते हैं या बाद में भी लिख सकते हैं. ठीक है, आप इसको जैसे मैंने यहाँ पे लिखा, इसको आप चाहो तो ऐसे भी लिख सकते हैं. You can write down as there are many such elements in the codomain which have no pre-image in its domain. Hence, the function is not onto. Hence, the function is not onto. I think it's clear. Same thing, the third part, fx is equal to x square. f is a mapping from r to r, real number to real number. ठीक है, इसको 1 to 1 कैसे करेंगे? ये 1 to 1 है कि नहीं हम चेक करते हैं. x1 x2 belongs to r, fx1 is equal to fx2. You are getting x1 square is equal to x2 square. When you take x2 square to other side, x1 square minus x2 square. x1 का आपको 2 इमेजेस मिलेंगे, x2 भी मिलेगा, माइनस x2 भी मिलेगा. अगेन द सेम थिंग जो यहाँ पे हुआ है. ठीक है, 2 एलिमेंट्स के आपको एक ही इमेज मिलेंगे. सो इट इज नॉट 1 to 1. ओके, व्हाट अबाउट ऑन टू? इट इज नॉट ऑन टू ऑल्सो. ये ऑन टू नहीं है. क्यों नहीं है? क्योंकि यहाँ पे भी नेगेटिव एलिमेंट्स जो होंगे वो किसी के भी इमेज नहीं होंगे. ओके, सो नेगेटिव एलिमेंट्स विल बी लेफ्ट आउट. सो यू कैन से दैट इट इज नॉट ऑन टू. सेम थिंग जैसे मैंने यहाँ पे लिखा है, इसी चीज को आप यहाँ पे भी लिखोगे. सो द 4th and 5th क्वेश्चन इज सेम टाइप, ओनली द डिफरेंस इज फंक्शन इज इक्वल टू एक्स क्यूब है. तो इसको आप एज अ होमवर्क घर पे करेंगे. ओके, इसको हम अगेन कंटिन्यू डिस्कस करेंगे, कंटिन्यू करेंगे नेक्स्ट क्लास में. ओके, तब तक के लिए आप जो भी क्वेश्चंस आज मैंने बताए हैं, प्लीज प्रैक्टिस एट होम and stay safe at home, and I'll be continuing the same topic in the next class. Till then, thank you so much.